Good afternoon, everyone. This is BremSter, and today I'm coming to you with a puzzle which, the minute I read the title of, I have words running through my head. This is a diamond in the rough, a shiny piece of coal trying to reach my goal. My power of speech unimpeachable. Only 19, but my mind is older. These New York City streets get colder. I shoulder every burden, every disadvantage. I have learned to manage. I don't have a gun to brandish. I walk the streets famished. The plan is to fan this spark into a flame, but damn, it's getting dark. So let me spell out my name. I'm going to solve the puzzle, actually. What's going on? I think the grand final vote is still up over on my community section. It may have just finished. Well, it's probably still there. So, yeah, let's go check that out. There's down to 2 puzzles. As of me recording this, I don't know what those 2 puzzles are because the semi-final is still running. Ooh, something very weird is going on. My audio has just gone completely bonkers. Maybe it heard me singing and decided to do that. Anyway, yes, Diamond in the Rough by fjam. So let's get straight into this. Normal Sudoku rules. I've bothered you enough. Normal Sudoku rules apply. In every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. It's a good thing I'm going into this with good spirits because this is a rule set that breaks my brain. So along each blue line, in each region, digits in each region must sum to the same total. So what that means is, for example, on this line, this digit will, or this cell, which is the, basically on this line, in this region, the line exists here. In this region, the line exists here, and in this region, the line exists here. So green will have the same sum as yellow will have the same sum as orange. Now, if a line has multiple disconnected segments within a region, these segments are summed separately. So that's going to matter here, really. So these aren't part of the same sum as this. So these are separate line segments. So it will be those, that, those, let's use a different color, blue and purple. So those are all individual sum segments. And orange has the same sum as yellow, has the same sum as green, has the same sum as blue, not these ones, that's a different segment I'm talking about. Green has the same sum as blue, has the same sum as purple. So, yes, the debate about whether these are region or equal sum lines, I don't care. They're just sum lines, and you then clarify within the rules which one they are. But this is how this puzzle works. We also have cells separated by a black dot must contain digits with a ratio of 1 to 2. Not all dots are given. So they're the rules of the puzzle. I'm going to restart the puzzle to restart my timer, and I'm going to hope I can figure out how this works because I am terrible at sum lines. So we do know that this is a minimum of 6. This is 6, 7, 8, or 9, because it has to sum these 3 digits, and the minimum I could put into those is 1, 2, and 3. Okay. Now, these 4, it's got to be this central thing. These 4 have the same sum as that, which have the same sum as that. But it's got to be something about this line. Oh, it doesn't have to be, but I feel there's something going on with those. I'm going to use a darker green. With those. Because we know all of this green and yellow have the same sum. Green and yellow have the same sum. Does this do anything? Well, this is in both, so I can take that out, and green and yellow still have the same sum. But this sums to this, sums to this, sums to this, so I can take all of those out, because this and this are going to have the same sum. And this are going to have the same sum. So this means that this is an even sum because green and yellow have the same sum. So this is an even sum, because whatever green is here has the same sum as yellow. And if I add yellow to green, whatever that is, it's going to be a sum plus itself is going to be an even digit. If it was 5, 5 plus 5 is 10, even. Whatever, if you double a digit, it becomes even. Now, but these digits are restricted. These can only be 1, 2, 3, 4, 6, and 8. Because you can never put 5, 7, and 9 on a black dot, because a black dot must have a low digit and an even digit on it. But these have the same sum as those. But I don't see how that's a restriction. But the other thing I've got to think about is, what can this be? Because it can't be 15. Because if it was, I mean, it can't be 15 because it's an even sum. If it was, okay, so ask what happens if it's as low as 12. Then these digits would have to sum to 12. All 4 of them would sum to 12. But these digits would need to sum, an entire row of a Sudoku is the digits 1 through 9. And the digits 1 through 9 sum to 45. Now, if these were 12, these would sum to 24. 45 minus 24 is 21. These would have to sum to 21. But these would be a subset of 12. But these would also be a subset of 12. So these would have to sum to 21. These would sum to 21. But these are a subset of 12. So the maximum they could be, like if these were... What the heck is going on? If this was as low as 12, these... Hang on, this... In order for that to work... I am very confused here. In order for that to work... Because these would have to sum to 21, with these being a subset of 12. But same... Arg math. If this... But if these sum to 9, these would sum to 3. And then... But this would be a subset of 21, and that would have to be too high. That doesn't work. The maximum I could put in here would be 6 and make these sum to 6 and these sum to 6. But if this sum to 6 and this sum to 6, in order to get to 21, that would have to be a 15. It doesn't work. And if these sum to 18, which is getting further away from 14, 16, the reason is 15 is the average that these could be, but they can't be 15 because they have to be even. So if I go further away from 14 and 16 and make them 18, this would be 18, this would be 18. 18 plus 18 is 36. These would have to sum to 18, but these would have a maximum sum of 9. And that wouldn't work because these would have to sum to 18. So these would have to be 9, or these would have to be 9, and either the column or the thing would break. So these are either 14 or 16. Okay. Now, if it's 14, then this makes up the difference, because 15, 15, I've got to add the extra 2. So 14, 14 is 28. This becomes 17. So if it's 14, these are both 17. If it's 16, these are both 13. Oh, God, there's math I could do here. I just can't understand it. So if this is 14, let's do it this way. If this is, no, not all three. If this is a 14 line, these have to sum to 17. And these have to sum to 17. But these 4 lines sum to 14. So the maximum these could sum to is 7, and this would have to be a 10. Because 14, and this is a 16 line. Because if this was a 14 line, these would sum to 14. These would sum to 14. Maximum each of them could be was 7 plus 7, because the same logic in the row is in the column. Maximum this could be is a 7, and you would have 14 plus 14 plus 7. 14 plus 14 plus 7, 28 plus 7 is 35, and this would have to be a 10. It doesn't work. This is a 16. These are all 16 lines. So 16 plus 16 is 32. This is crazy. 16. Sorry, everyone. Opening up my calculator. So, because I just need to take some notes. So, they are 16 lines. 32s. 45 minus 32. This sums to 13. But this sums to 13, but the maximum, hang on, this plus this is 16, so these sum to 8. So 16 plus 16 is 32 plus, this is a 5 in the middle. Which, of course it was going to be, but it is. So there's a 9 in one of these, with 2 digits that sum to 7. Because 16 plus 16 plus 8, these sum to 8. So they can't include an 8. I can't make them 1, 7. I can't make them 3, 5. And I can't make them 4, 4. This is 2 and 6. So there's a 3 in one of those. There's no 6 here. These sum to 8. They can't be, well, they could be 1, 7. They can't be 2, 6. They can't be 3, 5. These are 1 and 7, and there's no 7 here. Holy cow. Now, the 2 can't go with a 1. This is a 3, 4 pair, because the 2 can't go with the 1, because the 1 is in the 1, 7, and this is an 8, 9. Now, the 16 line, I can't put the 8 and the 9 together. The 9 needs 2 more digits that sum to 7. How do I do that? So one side, the 9 needs 2 more digits that sum to 7. I can't use 916. I can't use 925. It's 934. So this is in row 5. I'm taking notes here. So one of them is 934. I don't know which side it is. This is just me taking a note. And the other side, I haven't used 1, 2, 3, 4, 5, 168 and 168. No. It's not 168, it's 178. And 178 sums to 16. So one of them is 178 and the other one is 349. And that's how that works. But I don't know which one is which. Now, and this is in row 5. One of them is 178, one of them is 349. In the column, whichever I put the 9 with needs to go with 2 digits. So in column 5, I need to put 9 with 2 digits that sum to 7. I can't do 916. I can't do 925, so it is also 934. So it's 349. And the other side must have the 8 with 2 digits that sum to 8. But if it's 934, and again, I'm not saying that this is where it goes. It could go down here. I'm just saying what digits are left. 1, 2, 3, 4, 2, 6, 8, and 2, 6, 8 sums to 16. So on one side we've got 2, 6, 8, and the other side we've got 3, 4, 9. But I don't know which one is which. Okay. Now, we know this sums to 16. This sums to 16. This sums to 8 or 9. 16 plus 8 is 16 plus... So if this was an 8, 16 plus 8 is 24. That seems okay. 24 in 6 is fine. Okay, I'm not understanding. Is it... How do I make up 8 here without breaking this dot? 8 would be 1, 2, 5, which would leave 3, 6. No, that's fine. There must be a 1 on that. Because if there's no 1 on this, this is 2, 3, 4, and this has no fill, because it couldn't be 2, 4, or 3, 6. So there is a 1 on this, which puts 1 down here. If this is 8, this is 178, because I couldn't put the 1 here. There'd be a 1 here, this would be 178. If there's a 1 here, this would be 7, this would be 1, this would be 178. Now, if there's a 1 here, if this is 8, there's a 1 here, and this is 349. Okay, sorry about that. There's a heat wave in Melbourne at the moment, and our power went out. Now, that caused a flicker in our house, which was enough to interrupt the recording. I do have power because our house is now on battery. So I'm recording with my house on battery, but I should be good. I'll have enough power for many hours. So I'm not worried about that, but it did interrupt the recording, and I had to make sure the recording was good and everything. But what I did notice is... Sorry, I did notice this. I'd been asking about what was going on here. And I was like, if there was a 1 here, and I'd done some investigation. And now I've realized there must be a 1 here. Because if this is 8, there is a 1 here, because the minimum here would be 2, 3, 4, which would be 9. But if this is a 9, I had to put a 1 here anyway, because the only way to not include a 1 would be for this to be 2, 3, 4, and that would break that cell. So there is a 1 here. This is a 7. This is a 1. I can get rid of this coloring. Okay, now, 1 is on this line, which, opening my calculator again, because everything shut down. I was just out for a second, but that's enough. Now, in row 5, that means this is 178. I'd already calculated these options. So if this is 178, these are 349. So this is 349. So this can't have 3 or 4 on it. So it must have a 2, because otherwise it's 156. So there's a 2 on here, and it's either 125 or 126. But there is a 2 on here. And it's 125 or 126, which means there's an 8 down here. But there's also a 7 down here. There is a 7 down here, and I can't put it on the dot. So there's a 7 in here. There's an 8 down... wait a minute, there's an 8 down here. I can't put 8 on here because then this would be at least 1, 2, 8, which would make this too high. There's an 8 down here, which means this is the 9, this is the 8, and this is 1, 2, 5. Yeah, 5 and 3 is 8. And this, I'm not sure. But these are 1, 2, 3, 4, 5, no, 6, 7, and 8. And there's no 7 there. So this is either 3 or 4. Okay. Wait, no. This can't have a 9 on it, and I can't put 9 here. There's a 9 up here. So in the column, this was 3, 4, 3, 4, 9. Because the options were 2, 6, 8 and 3, 4, 9. So this is 3, 4, 9. This is 2, 6, 8. Now this can't have a 3 on it. So it's 1, 2, 5. And these are 1, 2, 3, 4, 5, 6, 7, and 8. And I can't put 7 onto a dot. So this is 3 or 4 because they're the only things in a ratio with that. 7 is on here with either 6 or 8. And this is hang on, 6, 7, 8. Oh, that means this is 2, so this is 4, which means this is 6 and this is 3. And this is a known triple. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is 1, 3, 5. So this is a known triple, which is 1, 2, 3, 4, 5, 6, 4, 7, and 9. But how's that going to work? Because that's the same as that. Minimum here is 13. Well, if this is 16, if this was 7, there must be a 4 here. Because if this is 7, 9, it'd be 16, and I can't make that sum to 16. Maximum I can make that is 15. So there's a 4 here. So if this is 4, 7, it's 11, and I can't make that sum 11. This is 4, 9. This is the 7. 4, 9 is 13. This has to sum to 13. There's no 8 here. This is the 8. So this is the 4, which means this is the 9, and this is the 4. This is a known triple. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a known triple. 1, 2, 3, 6, 3, 6, 9. But I could do the same trick. Maximum here would be 12 if this has got a 3 on it, but the minimum here is 13. So there's no 3 on here. This is 6, 9, which is 15. So this has to sum to 15. There's no 6 here. This is the 6. So this is the 3. 7, 8, and 6, 9. This is the 3. So this is a 1, 2 pair because it's the only way to sum to 3. 3 is down here somewhere. I was about to say there's no 5 on a black dot. Okay. These have to sum to 7. They're not they're not 3, 4. So they're 1, 6 or 2, 5. I don't know what to do with that. This and this have the same sum. Well, this can't have a 5 on it then, can it? Because if this is 5, 2, this would have to sum to 7. And there's no way to make that sum to 7. 1, 3 is 4, 1, 5 is 6, and 3, 5 is 8. If this is... Well, these are 2 odd digits, so this has to have an... These are 2 odd digits. 1, 3, and 5 are both odd. And if I add 2 odd digits, they're going to be even. So this has to have an even sum. So there's no 5 on it. This is 2, 4. This is the 5. The 2, 4 here means this has to sum to 6. So there's no 3 on it. This is 1, 5. This is 3. This sums to 6. So that's a 6, which means that's the 9 and that's the 6. These have to sum to 6. Well, the only way to sum to 6 is 1, 5, and 2, 4. So there's no 3 here. If this is a 3, this would be a 3. There's no 3 here. This is a 3 in the middle. That's 3 in the middle. That's okay, that's not a thing. So these are 1, 5, and 2, 4. There's no 5 here, so there's no 1 here. So these are not 1, 2, 3, 4, 5, 6. These are 7, 8, 9. There's no 7 at the bottom. That's the 7. This is an 8, 9 pair, taking 8 out of there. There's no 7 here. Six is here by Sudoku. That's 6. So 6, those two sixes put 6 in one of those two. That 6 knocks it out of there. That's a 6, which puts 6 in one of these 3. Unfortunately, can that be 6, 3? I think it can. Well, it can't be 1, 2, and it can't be 4, 8. So it's either 2, 4 or 3, 6. If it's 2, 4, it's 2, 4. And if it's 3, 6, it's 3, 6. So they're the only possibilities. But I've got the totals of the lines. So I'm getting an alert, probably because of the power stuff. Anyway, so this can't have a 6 on it. So this isn't 3, 6. So where's 3 in this box? It's in one. It's in one of those. This is where my Sudoku is going to fail me. Particularly considering scanning blue on blue is tricky. So these are from 1, 2, 4, 8. There's no 4 here. So there's no 2 here. I feel there's something going on with that 6 line. Where's 4 in this bottom row? 4 has to be down here. So this is the 4, this is the 2, this is the 1, this is the 5. The 1 makes that the 5 and that the 1. The 2 makes that the 4 and that the 2. There you go. It was these 4s that did it. It was the 4s that did it. There's no 2 here, so there's no 5 here. There's no 1 here, so there's no 6 here. The 5, of course, this is 6 and this is 1. The 6 looks up making that 7 and that 6. The 1 looks up taking 1 out of there. The 6 looks up taking 6 out of there, so there's no 3 there. But 6 isn't in either of those. This is 6, this is 3, which takes 3 out of there. This 6 takes 6 out of there. These are 1, 2, 3, 4, 5, 6, 2, 3, and 8. Well, this is 3 and this is 2 or 8. There's no 3 in either of those. That's the 3. There's a triple in this row. 1, 2, 3, 4, 5, 6. So these are 2, 5, and 6, and there must be a 5. There's no 6 there. Oh, this is just 6, and this is a 2, 5 pair. Okay, which means this is the 8, this is the 2, this is the 8, and this is another pair. 1, 2, 3, 4, 5, 6, 7, and 9. I don't know what to do with that 7, 9 pair. This 9 looks down making that 8 and that 9, which looks up saying that's not the 8. This 1 looks up making that the 2, so that's the 1, which takes 1 out of there. The 1 also makes that 8, that 7, that 1. So I've got a lot of stuff going on here. 1, 2, 3, 4. This column, 1, 2, 3, 4, 5, 6, 7. These are an 8, 9 pair. So 1, 2, 3, 4, 5, and 7 go into those. Which means 7 is up here, but I can't put 7 onto a black dot because you cannot put a high odd digit on a black dot. That is the 7. Which looks down making that the 9 and that the 7. This is a beautiful puzzle. Absolutely stunning. Absolutely stunning. It is just absolutely stunning, and I'm stretching this way too far. So, where is 1 in this column? Can't put 1 there because of that 1. There's no 1 in this box. So this is the 1, which takes 1 out of here. This is a 2 or a 5. 2, 5. What is this? Well, it's not 3, 6, and it doesn't have a 1 on it. So it's 2, 4, 8, and it must contain a 4, and the 4 is not at the top. That is the 4. The 4 looks down, making that the 9 and that the 4. This is a 2, 5 pair. So the 1, 2, 3, 4, 5, 6, 7, 8. These are 1 and 9. This 9 looks 1 looks across, making that the 9 and that the 1. The 9 looks back, saying that's not the 9. The 1 says that's not the 1. This also isn't the 1. This is the 1. This is a 2, 5 pair. So this is the 7 and this is the 5, which makes this the 8 and this the 7. The 4 makes that the 3. So there's no 3 there. This 4 makes this the 9 and this the 4. The 9 looks back, making this the 8 and this the 9. The 8 looks back, making that the 2, which makes that the 5, that the 2, that the 5. The 2 looks down, making that the 5 and that the 2, which looks down, making that the 5 and that the 2. And 1, 2, 3, 4, 5, 6, 7, 8. That is the correct solution of the puzzle. 192 solves. And I've obviously still got my cache loaded from solving gas puzzles this morning. That was amazing. You'll have to check the video time for my solve time. That was amazing. Absolutely amazing. Thank you, fjam. That was beautiful. And I'm still getting alerts from the power system, so I'm going to go check that. Sorry about singing at start. Well, a little bit. I'm a little bit sorry. Sorry, not sorry about what I sang. I'm just trying to have some fun. Thank you, everyone, for watching. And as always, good luck with your solving.